Hi everybody. I wanted to work on net present value in this part, and then I'll make another video to go through the other requirements of the project. Net present value is a matter of mapping out the cash inflows and the cash outflows of the project or opportunity or investment. So they give you the information, but it's your job to organize it in a way that allows you to calculate the present value of the future cash flows and then take that net of the original investment. That's what net present value is. It's the present value of future cash flows net of the original investment. This activity, this problem or requirement, presumes you've already studied present value, future value, and the time value of money. It may have been a minute since you did that. You may need to refresh. And you may have used the tables, and here we're going to use Excel. Time value money is easy when the dollar amounts are the same. So do you want $30,000 now or $30,000 in the future? You want it now, no problem. But what if your choice was $30,000 now, or $10,000 in 4 years, and $20,000 in 5 years, and $15,000 in 6 years, and maybe $4,000 after that? Well, those future promises aren't worth as much as the $30,000 today. So you need a mathematical way to make them equivalent. And the way to make them equivalent is to calculate the present value of those things that are in the future. And so we're going to do that. So the way I've done it is I've set up this grid where I've got year 0 is the initial investment on day 1, and year 1 is the end of the first year, end of the second year, end of the third year, end of the fourth year. The reason I just have 4 years here is because the useful life of the item, the equipment we're buying, is 4 years. So I've set up this grid, and I have a column for each of the items where there's going to be a cash inflow or outflow. So in a particular project, one of these things I may not need. There may not be a road renovation. There may not be operating costs. There may just be savings. There may not be receipts. So I have intentionally set this up so that there is a column for each of the things in the story. So let's look at the story. So Hookie Mines intends to replace a worn out industrial drill and get a new one. Okay. The company's required rate of return is 12%. We're going to be ignoring taxes. Taxes is a reality of life, and it is a payment that the project may need because it's generating profits that are taxed. But for now, we're going to ignore taxes. When you get into more advanced applications and upper level classes, that assumption may go away, and you'll have to calculate these things net of tax. The engineering department has calculated a number of things that we will need. And so the first thing is, what's the net present value of the project? So we have all these things. So and I've made a spot for each of them, and you would do the same. So on day 1 of the project, when you have to pay for it, you will have an outflow of $400,000. You got to buy the equipment, pay for delivery, and set it up. Then they tell you you're going to get the salvage value of the old when you sell the old one out. That's an inflow. So outflows are shown as negative and inflows are shown as positive. Working capital. So there is some working capital. And what that is that it takes time between when you produce it and then sell it and finally collect from the customer. So there's a delay between the beginning of the activity and when it finally results into cash. And that uses cash. Cash is locked up in that cash cycle, and so it's going to require $130,000 because apparently there's going to be quite a delay between when you actually use that drill and when you see cash coming in from that activity. But at the end of the project, that is going to be returned to you. So this is an outflow at the beginning, so that would be negative, and then it will be an inflow at the end. When you finally collect all the things at the end and you stop using this machine, you'll get caught up and that cash will be returned to you. Then it tells you that there's cash receipts each year. So that doesn't start on day 1. You have to operate for a little bit, but that turns out to be, that's an inflow. You're going to get that every year. So I'll put that in each of the 4 years. And then there's some operating costs. So those are outflows. So I'll put that in each of the 4 years. That's not going to happen on day 1. It'll happen during the first year, so we'll put it in like that. And then this particular project, and this is unique to this project, and there may be other things in other projects that are unique to those, but this project, in the third year, you've got to repair the roads because they get weathered. Okay, and so the road to the mine, I guess, needs some attention in order to take it all the way to the end of the fourth year. And then when you sell this new drill, you're going to get what they estimate is the salvage value. That will be an inflow. So now I have mapped out the cash flows in the years that I expected. And I set up these years here as numbers so I can point to them in a formula rather than write year one, which would be all alphanumeric and you couldn't put it in a formula. You could always do it manually, but I like it to be easy. All right, and so now this net cash flow is going to add up all the cash flow in each year. So I'm going to use the sum function. It thinks I want to sum those, but I don't. So I put my cursor there and drag and indicate what I want it to sum up. And then I can copy that formula down. Now, if we were using tables, we would go look up the table for what is the present value factor for 12% for 1 year. So let's work on the present value factor in case you're working with the tables. So we're going to, if you don't have PV in your recently used, I do, you put PV in the search function and hit go, it will come up. And then in here we would put the rate, which is 12%. The number of periods, you can put in 1. I'm going to click over here and select that one because then when I copy it down, it'll float down and pick up each of the years. There is no payment because payments are something that happen over and over. They reoccur every year. And here our cash flow is just for this year. It changes each year. So it's a future value amount. But I want the table amount. And so the table amount is going to be just a -1 because the tables are always done for $1. And -1 is because it's a future amount. And so it's expressed as a negative in Excel's logic function. You could put +1, in which case you'll get a negative table value, and it'll still be right. It'll just be negative. And type is whether it happened on the first day of the year or the last day of the year, and we're going to leave it as last day of the year. And it's because we don't want to confuse it with year 0, which is the first day of year 1. So you can leave it blank or you can put a 0, but if you put a 1, you're going to get slightly different numbers from us because you've changed the assumption about when during the year that cash flow occurred. So this is the factor that would map to your table, and I can drag this down, and it changes because it will change to 2 years, 3 years, and 4 years in the function, or you can go in and type it manually, either way. And so then to get the present value from that, you would take the cash flow in that year times that table factor. Now this is not rounded. So it's not going to match exactly with your table. Your table may have 5 decimals, 4 decimals, or 3 decimals. But this, if you were using your tables, this is how you would do it. You don't have to use this column. You can put the actual 153 in your function here. Instead of the -1, you can put the -153,000 and directly calculate this 136,607 if you prefer. But I know some of you were trained on the tables, and so that helps to map to what's already in your head. So these 4 amounts here, if you added them up, would be the present value of the future cash flows of this project. This is the present value of the future cash flows of this project. That is not NPV. NPV is net present value of the future cash flows. What is it net of? Net of the original investment. So the original investment is the net cash outflow on year 1, which for us is the net of 3 things, but it could just be one thing if there was no working capital and there was no old equipment that you were getting rid of. You just were buying some new equipment and it wasn't replacing an old one. So net present value is these 4, the present value of the future cash flows, net of the original investment. So to get net present value, I would add all of those up. Here, our net present value is positive. What that means is the present value of the future cash flows is returning better than 12%. And so we would accept any project with a positive cash flow. So this interest rate on this project, which we didn't actually calculate, but we will in later requirements, we know whatever it is going to be more than 12%. If this is negative, it means the project is returning something less than 12%. So that's the nice thing about net present value, is it immediately tells you if it's a positive number that this is an acceptable, meets the criteria, the minimum return. So in B, it says, should the project be accepted? Yes, the criteria is met. It is earning more than 12%. So that's net present value, and we'll start another video for you to review the rest of the requirements.